Next is the projectile motion on the inclined plane. Suppose this is the horizontal direction and this is a plane which is inclined at an angle of say beta, and an object is projected with initial velocity u at an angle of, this angle is suppose alpha. Beta is the angle of the inclined plane with the horizontal, while the alpha is the angle of the projection with the horizontal. And object takes this path and strikes the plane, inclined plane again. So it starts from A and again strikes the plane at B. So we have to find time of flight of the projectile and the range covered, that is A to B distance. We know that acceleration due to gravity is g is downward direction. Now we have to choose the our conventional directions or reference directions, and we have to free to choose the directions so that our problem become easier. So in current situation, it is better to choose directions along the plane and perpendicular to the plane. So if direction is taken along the plane upward, it will be taken positive, and normal to the plane, this along this direction, it will be taken positive. That means G is acting downward, so we can make its two components perpendicular components. So two perpendicular component parallel to the inclined plane and normal to the inclined plane will be in this direction. So we say this direction is say x, which is along the inclined plane, and this direction where normal to the inclined plane is y direction, and we give the component accordingly. That means component of initial velocity along the plane. Now this angle is alpha minus beta. That means this direction is x direction. This is x direction. And perpendicular to this is y direction. That means we can say ux is now u cos alpha minus beta. And uy is velocity along the y-axis. Uy component will be perpendicular to the plane, inclined plane, and it will be u sine alpha minus beta. Horizontal component is u cos alpha minus beta. Hence, we can write uy equal to, because it's upward, so it will be taken positive. It is u sine alpha minus beta. So these are our x and y component of the initial velocity. Now we have to find the what is the component of acceleration. What is ax along the x-axis and what is the ay along the y-axis. If we see this component of g is opposite to x-axis, so it will be taken negative. Similarly, ay, this is a component parallel perpendicular to the inclined plane and it is opposite to the direction which we have chosen positive, so it is also negative. Now we have to find the angle. If we take this is the g, if this is g, then this is a g ay and this is ax. This angle is beta. So if we make it, it is a right angle triangle, it is beta, then it is 90 minus beta. That will, if this angle is beta, this angle is beta. If this angle is beta, then we can write ax equal to minus g It is beta, so it is this component is g cos beta, and this component is g sine beta. And g sine beta is along x-axis, so we can write it is minus g sine beta, and ay is minus g cos beta. And is in such a way we have found ux, uy, ax, ay. And similar to the previous case, we can apply to find the time of flight. For time of flight, we have to find the time for which projectile remains in air under gravity. For that, if we check the vertical direction, in vertical direction, net displacement of the object is zero when it starts from A and reach at B. So, using the second equation of motion, S equal to ut plus half at square, we write S is zero because net displacement is zero. Initial velocity was, this is the initial velocity ux. No, this is uy because vertical motion is we are considering, it is uy. Uy is u sine alpha minus beta into t minus plus half. Now acceleration is minus g cos beta, minus g cos beta into t square. This implies that we can rearrange the terms and get, if we take t out, it will come half of g cos beta into t minus u sine alpha minus beta equal to 0. And this term is 0, that means either time is 0 or half g cos beta t minus u sine alpha minus beta equal to 0. This is not allowed because at t equal to 0 we have projected. After that it remains in air. So this option is not correct. Then we go with this. That means half g cos beta t. No, this is separate. Half g cos beta t minus u sine alpha minus beta equal to 0. That means t equal to 2u sine alpha minus beta by g cos beta. This is the time of flight of a projectile on an inclined plane when object is projected with initial velocity u at an angle of alpha with horizontal, while the slope of the inclined plane is, or the angle of the inclined plane is beta. In that case, flight time is 2u sine alpha minus beta g cos beta. You can compare this, the time of flight when the object is projected on the horizontal plane, that was 2u sine angle at which object was projected was theta, and it is oblique g. So we can compare this 2u, same thing. G here in that case we are using the vertical acceleration, but here vertical acceleration is g cos beta. So it is appearing here g cos beta. And theta is the angle of projection on the plane. Here angle of projection is alpha minus beta. So comparing this, it can help us to remember the formula. So it is important formula we have to remember. Next is we have to find the range. Range of projectile. Range is R, and R is here AB. That is distance between A and B. For A and B, again we use the equation of motion. So displacement along the x-axis, that is AB, it is equal to ut plus half AD square. We are using the equation S equal to ut plus half AT square. Because displacement is done in the positive x direction, so it is taken positive. Then ux, u means ux, and ux is u cos alpha minus beta, and it is along the this this is along the x-axis, positive x-axis, so positive, into t plus half. Along the x-axis, acceleration is minus g sine beta. So we use minus g sine beta and then t square. It is equal to. Now t, what is t? T is the time of flight. And time of flight we have found this is 2u sine alpha minus beta by g cos beta. And we substitute this t in this equation and we get u cos alpha minus beta into 2u sine alpha minus beta by g cos beta minus half g sine beta into now t square. T square is uh, 4u square, or we can write it is 2u sine alpha minus beta by g cos beta whole square. Check the common term. 2u sine alpha minus beta by g cos beta, it is common. 2u sine alpha minus beta by g cos beta, it is a common term, and rest is nothing is common, so we left with u cos alpha minus beta minus half g sine beta into 2u sine alpha minus beta by g cos beta. It is equal to, now we have to solve it and simplify it. G will be cancelled out by g and 2 is cancelled out by 2. That means we left with 2u sine alpha minus beta by g cos beta. U is again common here, so it is taken out. That means we left with cos alpha minus beta minus sine beta by cos beta into sine alpha minus beta. We take common or LCM cos beta. We take cos beta LCM and taken out, so it will be g cos square beta, and inside it will be cos alpha minus beta into cos beta minus sine beta into sine alpha minus beta. It is equal to 2u square sine alpha minus beta by g cos square beta. Now we can simplify it. It is cos A cos B minus sin A sin B. And from trigonometry, so we can write cos alpha minus beta plus beta. So it is equal to beta beta cancel out. So we will get simply 2u square sine alpha minus beta into cos alpha by g cos square beta. This is the range of an object on an inclined plane projected with initial velocity u, making an angle alpha with the horizontal, while the inclined plane make an angle beta with the horizontal.